So this is the second time I make this video, but the first time I didn't capture the audio. So things that are important when you're trying to find a scale factor. Well, you obviously want to know if it's going to be enlargement or a reduction, right? And obviously you want to use corresponding sides when you're dividing. So for this one, let's just, I don't know, pick these two sides, this side and this side, right? We got corresponding sides. And now small to big, so we had this, the small one, the small rectangle would transform to a bigger rectangle. So by what scale factor, right? So what do you multiply each side by to get the bigger, the measurements of the bigger triangle? And to do that, I'm just gonna, so scale factor, this is an enlargement, right? And we divide the on the pair of the largest the corresponding sides, we divide the larger, 32 divided by 16, and our scale factor is 2, which you already knew because this one's pretty obvious, right? How did the 16 become 32 times 2? How did 22 becomes 42 times 2? How did the 25 becomes 15 times 2? So the scale factor for the enlargement is 2. I don't believe there was no sound on that one. Again, from small to big, so let's just pick a corresponding side in this case. We can use this and this. Right, so we're going this way, so we had a little rhombus here, and it became a little bit bigger, but what factor did we apply to the smaller one to get the larger one? So how did the 10 become 15? So the scale factor, when it's an enlargement, we divide the bigger side of the corresponding pair divided by the smaller, and 15 over 10 is 3 over 2, which is fine. You can leave it as that. If you want to change it to a decimal, you can. You can want to change it to this, this you also can. So the scale factor is 3 over 2 or 1.5. So if you want to confirm, multiply 10 times 1.5, and you'll notice it does equal 15. Okay, so that was the scale factor used for this particular one. 3, find a scale factor using from big to small. So here it's a reduction, right? How that become that, and how this, what was the scale factor used for that reduction, right? So for scale factor on a reduction, we're going to divide it for this let's pick this corresponding side, by the way, and we're going to divide the smaller by the larger. And you can leave it as a fraction if you want. In this case, let's see what's best. Divided by 10, we get 0.75. Okay, or if you want to leave it as a, what do you call, fraction 3/4, that's also okay. And that makes sense, right? Because it's a reduction, and when it's a reduction, we know we're going to get a number that's less than 1, and both numbers are less than 1. So if you want to just, I don't know if you have time, and multiply 8 times 3/4 or 8 times 0.75, and you just to confirm, 8 times 75, 0.75, it does equal 6. And 10 times 0.75, it does equal 7.5. Okay. 4, find the scale factor going from big to small. So again with a reduction. So this big triangle became this, right? So the scale factor of a reduction, we're going to divide the small one by the larger one on the corresponding side. Let's pick, I don't know, 15 and 12. If you want to use 5 and 4, that's fine too. So the smaller one is 12, the larger one is 15. You want to simplify that, divide both top and bottom by 3, and we get 4/5. So the scale factor was 4/5. If you want to go crazy, I don't know, 0.8, but 4/5 is fine. So, and again, just to confirm, if you take 5 and multiply by 4/5, you take 15 and multiply by 4/5, you will see that you do get 12, and you will see that you do get 4. Okay, so there's your scale factor. And again, obviously, a number less than 1. Man, I don't believe. So again, this one, these next two questions, they went both. So pretend you went from big to small and small to big. So let's pretend big to small. So let's say we went from this triangle and we reduced it to that triangle. So for scale factor of a reduction, let me choose a corresponding size. So let me choose 9 and 6. You could have picked any pair. For 9 and 6, right? So if it's a reduction, it's small over big. 6 over 9, or I'm going to reduce it even more. Scale factor is 2/3. Now for an enlargement, so let's go the other way. So pretend that you had a small triangle and you made it bigger. Okay, what is the factor? What did you multiply each of these sides? How did the 8 times what became a 12 and the 10 times what became 15, etc. So for enlargement here, we're going to take the same corresponding size 6 and 9, but instead of 6 divided by 9, I'm going to go 9 divided by 6. And we're going to get 3 over 2. We can change that to 1.5, but I just want to stop here for a second and see if you notice something. You know, what do you notice? You'll notice that they are reciprocal of each other. Always. Okay, always. So going to the next question, and it says, let's do the same thing for the next question, right? Find how did P, how did this quadrilateral become Q, how did quadrilateral Q become P, right? So let's go from, let's use these two corresponding sides, the 4 and 5. So how did, I guess, P to Q, so from P to Q is in, so P to Q, obviously, it got bigger, enlargement. So the scale factor is going to be between, if I use a corresponding 4 and 5, if in an enlargement it's big divided by small, or we'll just leave it like that. So the scale factor is 5/4. Now, for reduction, so I mean going the other way, so imagine I had this quadrilateral Q, and I'm going to P. Obviously, he reduced in size, right? It got smaller. I don't even have to do anything. I just gotta find the reciprocal of 5/4, and the reciprocal of 5/4 is 4/5. And again, it makes sense because on the reduction, my scale factor has to be a number less than 1, which 4/5 is. And for enlargement, it has to be a number greater than 1, which 5/4 is as well. Right, so now it just becomes repetitive. Let's see, find the scale factor going from small. So from a small triangle, it turned out to be a bigger one. So it's an enlargement. So I'm going to use, again, 16 and 40, my corresponding sides. Scale factor for an enlargement is going to be big over small. So 40 divided by 16 divided by 8, 5/2. Okay, and if you went crazy, you can change that to 2.5. So every single number here, how did the 16 become a 40 times 2.5? How did the 14 become a 35 times 2.5? So it's obviously an enlargement. Okay, that's one thing if you're looking for enlargement and you get a number less than 1, so you know there's something obviously not right. So here, the arrow points to what's going on here. From this rectangle ABCD, we have QRST, and obviously it's an enlargement. So the scale factor. So let's pick this pair corresponding side to 12 and 18, right? So if it's an enlargement, we're going to take from the pair of corresponding side to 18, and we're going to put it over 12. And again, that's going to be 1.5. Okay. You can leave it like that, or you can leave it at that. Okay, it doesn't really matter. It's the same version of the same number, different version of the same number. Okay. So this one, they give you a scale factor, and they're asking you what will the resulting shape look like. So if you had a rectangle, 12 by 28 rectangle, and you apply the scale factor and use the scale factor of 3/4, what would your new rectangle be? Well, first of all, I know it's going to be a smaller rectangle because 3/4 is less than 1. So just got to multiply that by 3/4. I'm going to multiply the 12 by 3/4. Okay, so 3/4 of 12 is 9. So, right, and then 28 and 3/4 of that would be 21. So my new rectangle, it's going to be a reduction of measurements 9 times 21. So again, here is a 15 isosceles triangle, 15, 15, 10. And just by looking at this, we'll know it's going to be a bigger triangle. So take a moment to multiply each side. And if you want to change that to 1.25, that's even better. 15 times 1.25 equals 18.75. So these two sides here will be 18.75. So if I multiply that by 1.25, multiply this by 1.25, and I also am going to multiply this by 1.25. And that one is going to be 12.5. So my second triangle head is going to have those three measurements. Is that it? No? Oh. Gee, so this one, there's no drawing, so that's the challenge here. So let me draw the rectangle. It's an 8 by 6. And if it's enlarged, it's telling you that the rectangle is going to be enlarged. So I'm going to have a bigger rectangle. Just need to find the new measurements. And the scale that we're going to use is 3/2. So let's multiply this by 3/2. This by 3/2. So our height here is going to be 9, right? Because 6 times 3 is 18. 18 divided by 2 is 9. And 8 times 3/2 is 8 times 3 is 24. Time divided by 2 is 12. So we're going to have a 12 by 9 rectangle. So that's my resulting. The sides are equilateral triangles. So here we have a triangle that's 22, 22, 22. The scale factor is 1/3. So we're going to have a smaller triangle. Now multiply everything by 1/3 times 1/3 and times 1/3. So if you multiply, so I'll put it over here, 22 by 1/3, you get 22/3. I'm going to change that to a mixed number. So 3 goes 22 7 times, 1 left over, 1/3. So each side measures 7 1/3 units. Okay. The last two, what's the scale factor going from small to big? So obviously this rectangle, right, became this rectangle. So you can see it's an enlargement. But the one thing you, hopefully everybody notices, is that the units are different. So the units always have to be the same. So instead of 4 feet, I'm going to multiply that by 12, and I'm going to write 48 inches. 2.5 feet times 12, it's 30 inches. Make sure your units are the same. Now I can find my scale factor. So the scale factor of an enlargement here, let's choose these two corresponding sides. It's 48, the large side, divided by the smaller side, which is 8. The scale factor here is 6. And it makes sense, right? Because 8 times 6 is 48 and 5 times 6 is 30. So the resulting second triangle is 6 times larger in its measurements. Okay, so be careful. Units always have to be the same. And likewise here, we're going from big to small. We're going for reduction. Right, so this is going to be a reduction. So this is 20 centimeters, and this is 4 meters. But instead of 4 meters, which is pretty long, right? 1 meter has 100 centimeters, so 4 meters is 400 centimeters. So let's rewrite that. And in the reduction, on the pair corresponding side, we're going to use 20 on top, right? Small over big. Simplify, and we get is 1/20. So the smaller, okay, by the way, the picture is not to scale, but the smaller rectangle is 1/20th of the original. So that's the scale factor. So again, if you have 400, right, and you multiply that by 1/20, you get 20. So that's how this became that. Okay, that's it.